Hello, my name is Eric Hars, and I'd like to welcome everyone to the Convergence Data Classification Community Group. The topic for today is going to be avoiding critical classification pitfalls. The presenters will be Richard Turner, Eric Hars, and Megan Proctor. The setup of the presentation will be a 20-minute presentation followed by a 10-minute Q&A. And some of the key learning points for today, we'll be learning about common pitfalls companies can make and learn from these mistakes, learning of the alternative approaches, and some demonstrations to highlight better approaches. At this time, I would like to turn it over to Richard Turner.
Thank you, Eric. So the first, this is based on our experience in doing this work for the past 18 years. One of the common pitfalls that we see a lot of companies are just starting classification for the first time is the way they kind of approach building the initial classification structure, which they can call the data model or the schema. And typically what they'll do is they may start doing this in a spreadsheet, or they may try to do this in a PLM solution that supports classification. And what we typically see is the following problems when they take these approaches. You know, with spreadsheets, the challenge is it's not very collaborative, right? It's whoever has the master spreadsheet, very hard to kind of share that information, to see it real time, obviously not scalable for a large company. And with PLM systems, many PLM systems today support classification, but what we find in our experience is there are really systems that are set up that they're assuming that the data model is static, it's been defined, and it's really there for searching. And what we see is a lot of limitations in being able to support iterations and all the changes that we'll show you in a few minutes that you experience when you're initially building a classification structure, because it's a highly iterative process. Another thing that we typically see is a lot of these companies don't really have the experience or the knowledge of doing classification. They lack kind of the basic understanding and principles of classification, which we'll talk about. And they just don't really understand the fundamentals. So we're going to show you guys some examples of better ways of kind of managing the building of the classification structure. So Megan is logged in to our DFR Online application. She's under the Smart Class module, and she's got a structure opened up right here on the left-hand side. So this structure is being viewed through a web application, DFR Online. Everyone can see it. Everyone can see the status of the category structure at any point in time. And the colors on that structure, you can see different colors indicate, you know, what's been approved, what's being worked on. So you kind of know the status real time. And then she's on one category here called scroll compressors, and you can see to the right all of the attributes. She's going to kind of scroll through all the attributes that have been assigned to this particular category. Some of these attributes are set up as required attributes. Some are not required or read-only. And you can see all those properties to the right for each one of these attributes. So there's about 20 attributes that are on this category that someone could easily look at and have an understanding of that structure. So these are really important things to consider. Another thing is, if you look at the structure, we've seen companies, because they lack the experience in building structures, they may not go far enough in their structure. They may have a very flat structure. And one of the limitations they'll have is they'll lose the ability to share attributes across categories. It's a lot more challenging when you have a flat structure, and that will drive a lot of inconsistencies in the way you describe common components like compressors in this example here. Or they'll go the other direction and they'll define a structure that has got too many levels to it. And the reason why it has too many levels is they didn't really think about the attributes you'd apply to those categories. And some of those attributes, like we'll take the attribute type, if you add that to a category, your whole structure will shrink considerably just by adding like an attribute type or a modifier or a noun. Those basic attributes will help you kind of mitigate the amount of categories that you need. So that's another thing that we've seen with other companies that don't have that basic experience. Okay, we'll move on to the next pitfall. So the second pitfall we want to talk to everyone about is it's really important that before you put your classification structure out there in a production environment, that you've actually processed that structure against some data. And your legacy data is, you obviously have parts today that you need to classify. We highly recommend that you make an effort in classifying your legacy parts against this classification structure to be in a better position of moving forward in a production environment. And the reason why we say that is until you've actually applied data against that classification structure, it's not going to be complete. You're going to find all sorts of issues with it as soon as you start putting sample parts against that structure, and you're going to want to change it and you're going to want to iterate it. So it's really critical to do that. And we've met other companies that said, what we've done is we haven't classified any of our legacy parts, but we'll set up a classification structure for all new parts, and every new part that's being created, they can classify. And the major problem with that strategy is that works for your new parts, but how if you want to find and reuse existing parts? You don't have that ability because your legacy data is sitting there, it hasn't been classified, and that's a major issue that you're not solving, the classification solves. So we highly recommend that you classify your legacy parts before you go too far. Another point is it's easy to finalize the category properties. If you have the data, then you know exactly what attributes are required, which ones are not required, what the validation properties should be, what the LOV list should be for that particular structure. You really don't know any of those until you've actually looked at some sample data that you applied to the classification structure. To really make those final decisions, you need to have the data to refine the properties of the categories and the attributes and the LOV lists. Why don't we show you guys an example of this? So now Megan's logging back into DFR Online, and she's going to go into SmartFind. That's our search application, and we use this to test sample data against a category. So right now she's in the thermostats category. You can see the category path at the top. Actually, she'll show you how she got to it. So here she's at the very top of the structure, and she's going to test. What she's going to do is she's going to run queries against the data, against the classification structure to make sure it works. So she's going to go into thermostats, and she wants to make sure that the way they set up the categories and the attributes for thermostats will support the types of queries that she needs to run. So now she's in thermostats, and you can see all the key attribute data to the left. So she's identified those 3 attributes to the left as key attributes: sensor type, AC voltage, and flow load current. Those are the key search filters on the left. And then to the right, as she scrolls through the rest of the attribute data. So she's able to make the decision on which attributes should be key, which are the ones you want to filter on when you're searching for something like a thermostat, and which of the other attributes are more for reference purposes. And those are all to the right that she's scrolling through now.
And in working with a lot of classification projects, until you get this view here with the data and seeing where these attributes fall and what the data looks like, sometimes it's difficult to make those decisions on where you want the display of the attributes to be, and oftentimes what you might consider a key attribute as well, just as Rich pointed out. So getting this view here gives everyone that shared view to make those decisions during the project. So Megan also has an example of splitting an attribute.
Thank you, Eric. So, on the subject of running analytics and reports here, we have encountered some examples where maybe a client wants to split out an attribute that's already existing. In this example, we have the heat and cool stages. We would be able to go into our system and split the cooling from the heating and therefore create 2 new attributes. This was done because the client realized that once they saw the data in this format that they couldn't query the data properly, so they had asked us to change it.
Okay.
All right.
So next pitfall the last pitfall we have here, pitfall number 3, is you need a feedback mechanism as you're processing your parts against the classification structure, as you're collecting the data for your parts, which is all the attribute data. You need an easy way to review that information, to approve that information, to add comments. At that point, you're processing lots of data, your legacy data, so you need a mechanism to kind of manage that whole workflow. We're going to show you an example of how that can be done. Going back into DFR Online, this is the third module that Megan's going to go into. It's called SmartTrack. And SmartTrack is where we basically track all the parts through their life cycle. So the life cycle stages are described on the left. It starts with a parts list at the very top, and then works its way all the way down from validation to receive to data servicing, verify and normalize, customer review, approval, or rejection. So those are, those are our kind of life cycle stages. And this is basically how we kind of track the status of all the parts that we're working on, that we're classifying. So you want to show an example of a part that someone's had a chance. We'll show you an example of how of where you can add comments. So customer reviewed this particular part. She just clicked on the rejected parts, and every single one of these parts has some type of comment. So she's going to click on the first one. And this is the feedback mechanism that you have. This is what SmartTrack provides you. As you can see, there's a comment in here on this particular part. It looks like it needs to be reclassified into a different category. It's in the wrong place. And so that particular approval put those comments in, and that gets fed back to the folks that are working on the parts, and then they can make the appropriate changes. They can edit the part, and they can reclassify it right here, and they can close out that particular action item. So this can all be managed right within SmartTrack, and that way you're not emailing back and forth any proposed changes. It's all captured right here in SmartTrack, and then you know the status of where the parts are at any point in time.
Yeah, it's a great point. Oftentimes on projects, it's difficult to track individual part approvals and the comments and all the feedback, and collecting that into one view for the team to share really does make it a much more efficient process. I know we've worked through a number of these projects, Megan, and you've got a number of common examples of rejections that you've worked through as well.
Yes, that's correct. A few of the most common comments that we get on rejected parts are certain things, just as the example gave, where we need to have a reclassification occur, as well as adding or removing certain attributes. And the last example being maybe changing the unit of measure for the best visibility when you're in SmartFind.
Yeah.
So I think the main theme of our classification community group presentation today is everything goes back to you need to have the ability to iterate the classification structure. You need to have a tool that's flexible enough to do that. You need feedback mechanisms. You need to test the classification structure with data. And then you need a way to kind of track the data on every single part and the approvals and the feedback. So that's something that is really important.
All right, and that concludes the presentation piece. At this time, I'd like to open it up for questions. If anybody has any questions, please feel free to enter those in.
Okay, I've got a question here from Kevin. Let me read the question. How much data do you need to process before you can nail down the category structure?
I can take that question. We typically go through a sampling process on the beginning phases of a project, and we will sample a small portion of the data to help gather the initial feedback and make those decisions up front. Typically, we will sample, it's about a 1-to-5 ratio. So if we've got 100 parts, we'll sample the 100 parts, and then the full data set would be 500 in that example. And that's usually what we see. And it's a great way to kind of get the process going and make those decisions right in the initial phases so that we're not loading a bunch of data and then making large amounts of changes later on down the process.
Any other questions?
Eric, we've got a question here from Julie. What is the definition of an LOV?
LOV. So LOV is, there's a lot of different terms in classification. LOV, list of values, is the same thing as an allowed values list, what we call an allowed values list, which is, it's a list of values for, say, a string attribute. One of the things, as part of a data governance program, once you roll out classification and say one of your attributes on the category is material, you really want to avoid anybody having the ability to type something in there. You want to give them an LOV list to pick from, so that way your data will stay clean and consistent. So that's the purpose of these lists. They're drop-down selections that companies can make as they're creating new parts, and at the same time, you're keeping your data clean. You're not allowing people to type in 5 different ways to kind of describe the same thing, which I'm sure everyone has seen before.
Looks like we have another question that just came in here. What do you suggest for rationale to get the business units or enterprise to have legacy parts populated with attribute data?
So that's a great question, which is, to convince management to go and do this, there's an investment in people and time and cost. And one of the things that we've done to get past that hurdle of convincing management that classification is really important, we'll do, and this is on our website, you can check it out, we'll do a DVA analysis where we'll look at one category of parts and we'll process one category of parts. Maybe it's about 500 parts, and we'll collect all the attribute data for those 500 parts, and then we'll do a DVA analysis, data value analysis, where we'll analyze it for duplicate and near duplicates. And then we'll show the organization that, if you've got 20% duplicates and 30% near duplicates, that there's a significant cost savings that could be that they're not taking advantage today because they've got so many similar parts. They wouldn't have so many similar duplicate parts if they had classification, and they'd have a lot less parts in inventory. And you'll see there's documents on our website, but one part can cost $10,000 to up to $15,000, and if you can mitigate that cost, across 50 parts a year, that's a significant cost savings for just a small volume of parts.
Looks like we have another follow-up question to the LOV question from earlier. Can you import an LOV from a reference data management software or solution? I can take this, and correct me if I'm wrong here, Megan. We do have the ability to import LOVs into our software. So if we are able to capture that from another system, we can certainly load those into DFR. I'm showing another question here. What's the average level of attributes for each part type, commodity, or leaf node? That does, I'll take a stab at it initially. That will vary based on the commodity group that you're working on. It's hard to say what the average would be until we look at the different commodity groups and the groups of parts that we're looking at, because we have some cases where it could range from 50 attributes to 100 attributes. It just depends on the business case and the project scope.
Yeah, some components like valves may have lots of inlets and outlets, and they could have 50 attributes, to Eric's point. Or some products are much simpler and have much less configuration, and they may only have 15 attributes. So it really all depends on the complexity of the component of the part that you're classifying. Any other questions? We've got some good questions today. All right, I think we're good. I think unless there's no other questions, I just want to make another announcement before we conclude our meeting, that look out for those in the classification community group. There'll be an email going out this week. I think it's going out tomorrow, talking about what we have up on the screen here, DFR version 10, which we're real excited to announce. It's 18 years in the making. It's web-based classification, so look for that and the information on this all-in-one subscription model. We're excited to announce it. And thanks everyone for joining our classification community group. We'll be sending this webinar out in an email that you guys can distribute to anyone on your team that couldn't make it to the meeting today. Thanks everyone for joining us.